Let us talk more about shapes of NumPy arrays and also how to change those shapes. So let's create a simple array. A would be a NumPy array 1, 2, and 3, 4. Well, give me an error right away because I didn't import NumPy. So import NumPy SNP, and let me repeat this step. Okay, so I created this array, and by the way, this is a good point when it's worth looking at our variable explorer. We didn't use it much before, but once we start dealing with larger arrays of data, it actually becomes quite useful and convenient. So you can open a NumPy array. You can open a variable here, an object, and it will show you how the data is distributed. So columns and rows, and these are the indices it has. So you can do some manipulations here. We're not going to do it here. We'll use it just to see what our array looks like. All right, so we created an array, and we can print it, right? Let's say it prints it 1, 2, 3, 4. In fact, in memory, it will be saved as 1, 2, 3, 4 in a consecutive order. And there are ways to return a different view on the array. And there are two, so the shape of this array, so let me return the shape of this array, right? Well, it will be 2 by 2, obviously. But you can actually get a view like this. And there are two ways to do it. So, and they're very similar, yet they're different. So there is a method called flatten, and there is a method called revel. So if you do flatten, it will create a copy of the array. So let me do b equals a flatten, right? And if we look now here, in our variable explorer, b would be this one column. B would be an array of a different shape. So if I do b shape, it will be 4 by 1, right? Another option to do it would be to revel the array. So this will be different things. So I do a revel, right? And C, as you can see, looks exactly the same, but there is one big difference. So flatten actually it creates a copy of our initial array A, and revel just gives another view. So here is what will be different. So let me change one element in my array A. Now let's say 0. All right, so you can see here, well, here I have 0 instead of 1, and you can actually look at the other variables here. I'll print them, but you can see them in the variable explorer. So if I print my B, well, B is not changed because it's a copy of that data. But if I print my C, well, C will be changed because it's just a view on the same data stored in the array A. So let's see how we can change shapes of the arrays to something different rather than, well, flattening it. There are two other methods for that, resize and reshape, which also will be slightly different. So let's create a new array. A is NumPy and space from 1 to 4. 1, 4, 4. Okay, it's overwritten our array A, right? And now, well, I can print it, obviously. And now I can resize it. Okay, A resize 2 by 2. Look, our array A here in the variable explorer changed its size, right? It's now it's an array 2 by 2. It's the same data, it's the same object, but it has now different different shape, right? So what's important, this method resize does not return a new array. So if I say b equals resize, a resize 2 by 2, right? My b will be none. So if I print b, it will be none because it doesn't return anything. It performs a certain operation on the array itself, but it doesn't give a new array. So another way to do it, let me recreate this A as it was initially. So 1, 2, 3, 4, and if I do reshape, then it will return me an array. However, it won't be a new array. It will be actually a new view on the array A. So A reshape 2 by 2. Okay, so B now is this array 1, 2, 3, 4 with a shape 2 by 2. However, now if I change my A or if I change my B, the other object will also change because they are stored in the same locations in memory, and the only difference is a view on them. So let me do the following. I do B, I can print B to begin with, and then I do B, let's say 1, 1 equals to 0. I do print B. Well, obviously the last element in B changed, but then if I do print A, it will also be a changed array. So that's the difference between resize and reshape. There is one more thing you can do with your NumPy array. So let me proceed with more examples on reshaping and introduce also the transpose method. If you recall your linear algebra, transpose is exactly what you would do with matrices, right? When you actually change the elements from ij, so for matrix A transposed with elements ij, they are equal to the matrix A elements ji. So if I take let me take a new array, x equals NumPy space, let's say from 1 to 6, right? And let me reshape it. So y would be x reshape 2, 3, right? So this will be this array. Let me open it here. This is my x, and this is my y, right? 1, 2, 3, 4, 5, 6. So now I can actually, well, first of all, I can reshape it from the shape 2, 3 to the shape 3, 2. It's not necessarily, reshaping doesn't necessarily work with a one-dimensional arrays. You can do it for two-dimensional arrays, right? So I can do z equals y reshape 3 by 2. Okay, so this is my array z, right? So it's 1, 2, 3, 4, 5, 6. And let me do the following. Let me also introduce a new array t which is obtained from y by transposing it. Transposing in the sense of transposing a matrix. Transpose. And if I look at my t, it will be something completely different, right? So t is this array 1, 2, 3, which used to be a first row, and now it became a first column, and 4, 5, 6, which was a row, and now it became a column. And finally, there is an alternative syntax for transposing. I want to say that you can introduce t as y dot t. That's, again, gives you the transposed matrix.